Okay. Thank you for coming for this light session. You guys probably ready for dinner, so I'll try to keep it short. My name is Jacob, and I work for Microsoft. And you can find me on my blog, jg09.net. You can find more about me over there. This is my personal blog when I blog about stuff I'm doing overnight, but also some interesting stuff I'm doing at work, because I work for Azure Management Portal team. I had a talk about how the Azure portal is built earlier this morning, so if you missed it, I encourage you to check out the video. I'm also on Twitter, so please follow me and tweet me if you have any questions. So this is the Azure Management Portal, the talk I had earlier today. And I also have uploading my talks to my YouTube channel, so you can go there through jg09.net/YouTube. It will redirect you to my YouTube channel, and probably my talks from today will also be forwarded over there. I am a software engineer, but I also love biking, and here I am on top of Mount Evans. This is in Colorado in the United States, and this is the highest paved road in US, and the oxygen level on top is 50% of what we have here. So that was a pretty epic climb, around 40 kilometers, starting from 7,000 feet, which is like around 2,000 meters, and 40,000 feet is like 4,000. So that was a pretty cool journey. And I live in Seattle, and I love Seattle because there is a lot of opportunities to swim, bike, and run. And I do triathlons, I ride bike rides, and I encourage you to come and visit Seattle sometime and take advantage of all these benefits that Seattle have to offer. All right, so let's talk about coding. So I've been writing a lot of C# code before I started with JavaScript, but at some point a few years ago, JavaScript happened, and most of developers who are writing mostly Java or C# has to learn JavaScript. And then code bases on JavaScript started growing, so this GitHub repositories count, and you can see like around 2011, 2012, the JavaScript became a leader. And then you can also see this on the job offers, that again, the market for JavaScript developers around 2012, 2013 was the highest, and I think it still is. And this is like very interesting thing, because here you can see that around 2013, 14, people were learning JavaScript hard, because if you search for undefined, it's not a function at that time, it was the count of searches increased dramatically, and then you can see that around 2015, the people already learned that, so the trend went back to what was before. And everything started over 20 years ago with Netscape browser. I don't know how many of you remember Netscape browser. Whoa, like most of the room. Excellent. Wow, that's cool. So Netscape wanted to add this dynamic language that will allow you to do some dynamic actions, which in 90s was like very, very cool thing. And this guy, Brendan Eich, was asked to create a language that will allow you to do these dynamic operations, and he had 2 weeks. And he did it in 2 weeks, and it was working. It was fine. Netscape had market at the time, and as everybody was thinking that the JavaScript will eventually die because we will need like more powerful language to run on the browser. Many people were thinking maybe it will be Java and maybe it will be Silverlight, but then this happened. Internet Explorer 6, and you probably might think that, oh, what are you talking about? This is like the worst browser ever, right? But 15 years ago, that was the best browser ever, because it is the first browser that implemented AJAX, which is asynchronous JavaScript and XML, which allows you to do requests to your backend. And then, thanks to AJAX, JavaScript survived. And after that, this guy, Douglas Crockford, so-called godfather of JavaScript, started evangelizing and convincing people that JavaScript is not bad language, like all of these people who are Googling for undefined is not the function. And he was also showing that a lot of quirks that JavaScript has are actually not that bad. And he wrote this book, JavaScript, The Good Parts, that is basically an overview and comparison of JavaScript language to Java and C#. So if you're like standard object-oriented developer, you could just check this book. It doesn't have introduction to for loops, if else. It just goes to the differences between languages that most of developers were used to and JavaScript. And this book is very nice because it's less than 200 pages, so you can actually read it. I strongly recommend it. And after that, different JavaScript frameworks started popping up one after another. Node was very big in this in JavaScript success because probably today many web applications are running on Node.js. And it was a few years ago, one guy said that an application that can be written in JavaScript will eventually be written in JavaScript. And that was Jeff Atwood, the co-founder of Stack Overflow. And it was 2007, so it was 10 years ago. And he was partially right because now most of the applications were rewritten to JavaScript, or we are just writing most of the applications in JavaScript. And our applications are becoming more and more sophisticated. If you look at the Chrome developer tools now, this is almost like small IDE inside the browser. It has many features. Debugger is sometimes even more sophisticated than Visual Studio or Eclipse. And now you're able to create web applications with almost native experience. And also you can create games. You cannot distinguish that this game is running actually in the browser versus this is a native operating system game. And if you do full screen, then you have like totally no idea that this is running in the browser and it's written in JavaScript. So all of this was very cool, but after some time we got to this problem that this is how the average JavaScript application architecture looked like. And because JavaScript is dynamic language, if you try to change one bit somewhere there in the middle, you're in big trouble, right? Because you don't know whether you'll break something or not. Maybe you'll be lucky, maybe not. So the rule of thumb was like, it works, don't touch, right? And this sort of was a problem. People started doing different tricks, such as, okay, this module is working. We are sure it's working. It was written by 2 years ago by the guy who left. So let's just wrap this module by another module, and then you end up with something like that. So a few years ago, TypeScript was created to address this issue, and the solution to address this issue was to add type definitions. So TypeScript is typed superset of JavaScript. So ECMAScript 5 is the version of JavaScript supported by most of the browser all the way back, I think, up to even IE6. And now we have the newer version of JavaScript that are not fully supported by the browser. It was called ES6, now it's called ES 2015, and now we just call it JavaScript vNext. But what TypeScript is doing, it's supporting this new language features, and it's transpiling it back to ECMAScript 5, so you can run it in the older browsers. It can also transpile it even to ECMAScript 3, which allows you to go back and support browsers that were created 10 years ago. So that's one feature. Another feature that TypeScript is adding is types and also annotations. But annotations probably will make it to JavaScript sooner or later. Types probably not. So TypeScript is adding this type checking. And to show you why this is solving some problem, let me open Sublime. So I'll make directory test, and I will open Sublime, very cool editor, and I will create new file, and I will call it hello.ts. So if you create simple JavaScript function and you take first name and last name as the parameters, and you want to print this to the console and say hello plus first name plus space plus last name. And here you can call it, say Jacob Jedrzejczyk. And this is a JavaScript code, but it's also TypeScript code, because TypeScript is superset. which means that every valid JavaScript code is also valid TypeScript code. And the only thing I have to do to run it is to compile it. And you can download the TypeScript compiler from typescriptlang.org, or you can install it with npm. I've already done it. And I can go to my console, and I can say tsc hello.ts. And this will produce hello.js file for me. And I can run this file, for example, with Node. And it will say, hello, Jacob Jedrzejczyk. So now, everything is cool here. But in large systems, the problem appears when this is in one part of the system, and this code is written by one developer, and this is somewhere else, and this is written by some other developer. And then one day, developer one actually let me open the JavaScript file, because this is what would happen in JavaScript world. So this is dev2, this is dev1, this is let's assume it's in different files, and developer one is like, you know what, I will improve this function. I will say person here, and this person object will have first name and last name, right? And he will, of course, tell every of his friends that, hey, please, you know, if you're like calling this hello function, now we change API, so you guys please update that, right? And, you know, everybody will say sure, but, you know, there will be this one developer who's on vacation right now, and he won't do that. And when you run the system, you might not even notice, right? You know, something is wrong. You don't get any error. You just get like undefined, undefined. Well, if this is not critical path in your system, you might not even notice for months, right? And then after 2 months, you discover, oh, we have an error. And then to debug which change caused that is very, very hard. So how TypeScript can help you with this? When you do this change, say person, and here I say person.first name, person.last name. And then I try to compile this. I have actually a TypeScript plugin installed with my Sublime. So if I click Command B, I can compile my TypeScript. And here I am getting error that supplied parameters do not match signature call. And here you can see I'm getting this error even nicer. It's big red thing, right? So the developer one who did this change, he can see that, oh, it has to be updated here, right? And then, of course, I can here specify an object and say first name, Jacob, and last name, Jedrzejczyk. But this is not very cool. In TypeScript, you can do better by introducing a class. So I can say here, I have a class person, which will have first name, which will be string, and also last name, which also will be string. And this function will take the person object as a parameter. And then this developer will know that he has to supply this person object here. And if he is typing hello, here you can see it's telling me, oh, it's accepting one object type of person. Okay, so I need to create this new person object. And then I have to say person first name is Jacob, and person last name is Jedrzejczyk, and I'll pass this here. And if I compile it now, I'm not getting any errors. And if I run it here with Node, everything still works, right? And you can even do a little bit better. I hope this is not, let me make it smaller maybe. How can I make it smaller? All right. You guys can still see it? All right. So I can also add the constructor here, like in C# or Java. And I can say it's first name, string, and last name, which is string. And here I can say this first name. And I'm getting nice IntelliSense also, that I have two properties on my object. Say last name. And now I can create this object. I can pass my first name and my last name directly here. And again, I can compile this, and I can run this with Node, and everything is still working, right? So this is cool. I have a class, I have this function. Well, of course, I can move this function inside my object. So I don't need a keyword function anymore. I'll just have this hello. I can get rid of this person parameter because I can use properties of the object. And now this code started looking almost like C# or Java. And here I will just say p dot. And you see I have a hello first name and last name. And I can also make first name and last name private because I don't want to expose this. And now if I say p dot, I only see hello method. Okay? So this is what developer wants me to call it. You know, in JavaScript, you can of course call every method on the object because there's no notion of private really. So I'll save that. I'll compile it, and I will run this, and still give me the same result. So what else we have in TypeScript? We have interfaces. So we can create interface. Let's call it printable. And let's say I want to have one method print that returns nothing. You can specify the return type. So like, for example, in my hello here, I don't want to return anything. And now if I say here implements printable, and I will try to compile it, and I will get an error that class person does not implement printable interface. So I need to implement this print method. So I'll do this. I'll say void. And actually, what I want to do here is in this method, I'll just return the hello, return string here. And here I will just call my hello method. I will say console log this. And I'll compile this. And it's still working. And now if I go here, whoa, it's not printing. That's not, oh, because I'm calling hello method. I have to call p. Actually, I can say create printable object. And now it will not compile because I'm calling hello, which is not defined on the interface. So I need to fix this, and I need to say .print. And again, I compile this. I'll run this. And I still have the same result. But now I have interface, I have classes, and I have this type checking in my code base. You also can do inheritance. So you can create a new class called, let's say, developer that extends my person object. And let's say I will add here a property called, what property? Let's say skills, which will be string array. And here I will create a constructor, which takes my first name, which still takes my last name, and also takes the skills, which will be array of string. And here, did something wrong? Sorry, say again? The name of the class. Oh, this one? I think that's okay. Maybe it's because I'm not doing this. Because here I'm calling the base constructor. Okay, now it's not complaining. All right, so you can see it's even giving me hints some that, oh yeah, here you go. So I need to, it's telling me I need to call the base constructor. So here I'm calling the base constructor, passing the first name and last name. And so this is not a problem in TypeScript because you cannot call the property without invoking the this property. So like, if I call it skills, then if I call it s and I try to do skills, it will tell me that this doesn't exist. I need to say this.skills, right, and then s. Okay, so in this method, what I can do, I can override my hello function. Okay, and actually let me change this to use template strings, which is a feature of ES6, and it's a little bit more readable. Boom, boom, boom. And here I'll override the hello method, say string, and here I will say let s equals super.hello. So it will print me this, and then maybe plus, I'll use again template string, and here I can print array, but really what I need to do here is say this.skills and say join, I think like that, and it should do the job. But now I need to create new developer, and I need to add some skills. So let's say I know C# and TypeScript. All right, so let's see, and this should compile. Oh no, is neither void hello. Oh yeah, you're right. Thank you. Whoa. Return. All right. Compile and note, and it's saying hello Jacob Jedrzejek, C# TypeScript, and actually probably I should say your skills are boom and add some space, and I can still compile this and can still print it. And you can see that here my code is almost like a Java or C# code. Let me go back to slides really quick. So at the very beginning, like you see, I've started from JavaScript code. I just compiled it with TypeScript, and you couldn't really distinguish whether it's already TypeScript or it's still JavaScript. So parts of your code can be still JavaScript. You can still use JavaScript, and you can have different parts of your system in TypeScript. And this is very cool when you're planning to migrate to TypeScript. You can still take your existing JavaScript modules and you can start writing new parts of the system in TypeScript. Or you can just rename the extension from JS to TS, try to compile it. If you get some compilation errors, that means you have a bugs, so you can fix it. Oh, and by the way, TypeScript was created by Anders Hejlsberg, the creator of C# and Turbo Pascal, and it's very cool that that now he's one of the main developers in TypeScript. And you know what is even cooler? Like if you go to GitHub, I was actually personally surprised by that. So GitHub TypeScript, I think. Whoops, not really. Let's see, TypeScript, Microsoft TypeScript. And if you look at contribute, maybe commits, somewhere here we should have Hejlsberg. Is it here? Wow, maybe he's on vacation right now. But he's actively contributing here. And what was his, I think, yeah, here we go. He just merged pull requests, sure, but here he added some tests, he added new baselines. So he's actively writing code. You'd think that he's some guy who is just manager who's telling people what to do, but he's actually writing code of the TypeScript compiler. So I think that's pretty cool. And this is the code I more or less written, and you can see that it's even more similar to C# than it's similar to JavaScript. I don't know if it's a feature, but I think this is a direction that we are trying to accommodate all these developers who spend so much time, learning C# and Java, and now we want to make them switch to JavaScript a little bit easier. So that was a very, very easy and small application. But in real world, what you would like to do, you would like to be able to use probably existing libraries. You would like to automate your development. And the tools that you would use, it might be NPM for managing your packages, because you still have JavaScript libraries on the runtime. So you can use every package that is available on NPM. And you can use Gulp for automating your development. Gulp has a lot of plugins for TypeScript compilation or for running tests, and even for automatic TypeScript compilation. And also to run existing JavaScript libraries with TypeScript, you can use definition files. Definition file is sort of like a header file for your JavaScript library that allows TypeScript to determine the types of different functions and its parameters. But this is option that you would use yesterday, but today you could do better, and you could use Yarn, the new package manager that many hipsters are very, very passionate about. And also Webpack, which is a tool that enables you not only to compile TypeScript, but also to manage your dependencies, to bundle your modules, and this is like sort of replacement of require.js. So let me show you how we can create simple app using Yarn and Webpack. So I'll create new directory, and I'll call it my real world application. So I'll say my real world application, and here I'll open VS Code. By the way, it's a pretty cool code editor. And I will start from index.html. I will say HTML, to make it a little bit bigger. Say HTML, head, title, my real world TypeScript app. And here I'll create the body. And what I want to do here is create simple to-do list. So I'll have input tag with my to-do item, and I'll have a button, sorry, new line, button that will add this to-do item to the list. And here I will have my to-dos, and I will have a list of them. And I will be adding to-dos from here on the button click to my list. So let me run and make sure this is working. I'll spin up HTTP server. I'll open it up, and you can see here my new to-do. And of course, it doesn't work because I don't have any JavaScript logic yet. Right, so let me add that. So I'll say here script source equals app.js. And instead of creating app.js, I'll create app.ts. And for now, just to make sure everything is working, I'll say console.log app loaded. I'll save this. I'll go back to my console, and actually let me open a new tab. Dev my real world app. Oh, sorry, it was TS, my real world app. And here I will say, sorry, let me make it a little bit bigger. Whoa, I didn't want to do that. And I'll say TSC. Oh, come on. TSC app.ts. And it produced a JavaScript file for me, which is exactly the same. Not a surprise. But now if I go here and I open my console and I refresh that, it should say uploaded, but it's not saying that. Oh yeah, thank you, sir. Boom. So now it's working, uploaded, and let me make this also bigger so you can see it. So my sort of end-to-end workflow is working. So now let me implement the logic of the app. So as every developer, in this case, I want to use jQuery. So first, let me add jQuery to my app. So I will use Yarn for this. I will say Yarn add jQuery. Yarn has much nicer interface than NPM. It's also a little bit faster, so this is pretty cool. And now it should add node modules, and here's my jQuery and my minified version. I'll just copy the path, and I will add the script here. Source, and close the script correctly, and I can get rid of this just for readability. And now in my app here, I want to add the click handler for my add button. But you can see that here I am getting the bridge squigglies. And this is because TypeScript doesn't know anything about jQuery. And there are two ways how I can work around this. I can say declare var $, and this is basically saying, hey, like if I say $, don't type check this for me. I want to write some dynamic code in this function. But what is not nice, I'm not getting any IntelliSense here, right? So if I say click, everything will be fine. But again, I'm not getting IntelliSense. So to get IntelliSense, as I mentioned, you can use type definition files. And there's this big repository on GitHub, which is called definitely typed. And it has thousands of definition files for different JavaScript libraries. You can see here almost 2,000 different JavaScript libraries. So there's some Angular library. If you can go to DTS, because definition files usually have extension .d.ts. And this is a description of Angular JavaScript library. So I can install this. I mean, I can copy it from here. So I can find jQuery definition file, copy it, add to my app, and reference it. But I can also install this with Yarn, or with NPM. Because back in days, there was this definitely typed tool called TSD that allows you to only manage definition files. But now we can use just one tool. So I'll say yarn add types. So you need to say add types /jQuery. And this should install types here. Okay, VS Code didn't refresh that. Let me rerun that. All right, here you can see I have types and I have jQuery index DTS, and I can reference this definition file here. So I'll say node modules /types/jQuery/index DTS, and now TypeScript compiler is not complaining about me using $ here, and also when I say dot, it's giving me IntelliSense. So now I can say click, and it's telling me that click function has 3 overloads, one with handler, one with event data, one that can be empty. I'll use one with event handler, even I won't be using it yet. And here I will get my to-do text, which is in to-do input field. So I'll say to-do, to-do.val, and again I'm getting a nice IntelliSense here. And then I'll grab my list container, UL to-dos, and I'll append using template strings this to-do to the list, and I will save that, and I'll go back to my command line. I will compile my TypeScript file, and I'll go back to my app. I'll refresh it, and now if I say my first to-do, click add, it's adding it to the list. My other, make it a little bit bigger, my other to-do, and it's adding it to the list. So this is a simple TypeScript and JavaScript workflow today, but you probably would like to automate this development, right? Because every time I'm here, I have to go back to my console, and I have to say TypeScript compile this file for me. So I will automate this using Webpack. So I'll say yarn add Webpack. And I also say yarn add TS loader, which will help me to compile my TypeScript files. And somewhere here I had probably here I had a config file for my Webpack, so you don't watch me typing it in. So I'll add this to my project. I'll call it webpack.config.js. This is a standard convention of naming Webpack config files. And what I'm doing here is I'm saying that my scripts are living in a source directory. So let me move my app.ts to source directory. And I'll remove my JS file because I won't need it anymore. And then it's bundling these files, and it's outputting it to this directory. And it's the naming convention is the name of my script .bundle.js. And here I'm using this TS loader to compile my scripts. And also I need to add with yarn the TypeScript compiler locally. And I also need to add tsconfig file to tell Webpack what files I have in my projects. And I also had this somewhere here. All right. Boom. This is a standard TypeScript compiler, which allows you then, if I am here and I say tsc now, it will just compile my files based on the tsconfig.json. Actually, let me switch to my real world app. So if I say tsc, it will compile my files, and here there's some error because I didn't update this path. I need to add ... and now it should be good. So I don't need to specify the name because the name is taken from tsconfig. Okay, so after this ceremonies, now I should be able to run Webpack, and it will tell me error in app.js. npm install. I think I added it. Yarn. Oh yeah, I added it to the wrong project. Sorry. All right, now I should have TypeScript. And now it's compiling, and now it output my bundle file, app.js. And by the way, I'm also using the minifier here. So this webpack.optimize.uglify.js plugin is automatically minifying the JavaScript code for me, because this is what we usually want. We want to build our project, we want to minify it. So Webpack is doing all of this for me. And what else, if you run Webpack with parameter watch, it will continuously watch for my changes and recompile this on every change I make. So let's see. First, let me update my index. So here I need to say this / app.bundle.js. Let's see if it's still working. I'll go back here, say my to-do, and I click add, and it looks like it's still working. And now in my network tab, I should have app.bundle.js. All right, so everything is in place, so that's nice. And now let me start making changes to my app. So here I have this console, and here I have my editor. So let me move side by side. So I go to app.ts, and the first change I would like to make is, like, when I am adding new item, it's leaving the text here, right? So I will have to, I would like to get rid of that. So let me close this code, all right? So I would like to clean up this field. So I will say $todo.val and make it empty. So I'll save that, and Webpack rebuild the file for me. Now I will refresh that, and I'll say my to-do, click add, and it's clearing up the field for me. So let's do one other quick improvement. Let's say I would like to also be able to add the to-do item on enter. So I'll create new handler, this time on my to-do item, pound.keyPress. Here I'll say event, and if event.keyCode, and you can see I am having nice IntelliSense from the typings file, and the key code for enter is 13. Everybody knows that. And here I could copy this code, or I could just extract the function add to-do, and paste this code here, and then use this function in here and also in here. And again, Webpack rebuild this for me. I refresh that. I say my to-do one. Okay, go to the beach and have a drink. All right, so everything is still working. And what I can also do with Webpack, I can bundle my jQuery into this one module. And how to do that? I can get rid of my reference to the typings file. I can just say import star as $ from jQuery, and TypeScript will take care of types because it's using convention to detect all the typings. And now Webpack produced for me bigger bundle.js file, and you can see that jQuery is now in here. So now in my index HTML, I can get rid of jQuery. So it's not specified explicitly here. I only have my module that is using this one library. So I'll again go back here. I'll say my to-do, and it's still working. And now in my network tab, I am only loading one file instead of two. So here it is, this app.bundle.js with jQuery embedded in it. And I can do this with other libraries. So let's say I also want to use Lodash in my app. So let's say I say yarn add Lodash and yarn add types/Lodash. Lodash is an improvement over underscore. It's more performant, and it's a library created by John David Dalton, who is now working at Microsoft, but Lodash is his overnight project. And what is actually a very cool thing, if you go to his GitHub account, John Dalton, you can see that he is committing code every day. There's no single day when he didn't commit code. Okay, he didn't do anything yet, but now in Seattle is still, I think, night, so he still have a time. But over the last 365 days, he was all the time committing code. So this is pretty cool. And here's the Lodash, which have 21,000 stars. So that's pretty cool. So let's take advantage of that. Let me run my Webpack watch. And I'll add some Lodash to my app. Say import star as underscore from Lodash. And let's say after adding the to-do, I just want to say console.log to-do count. And here I'll use Lodash. Let's say, again, I'm getting nice IntelliSense. I'll use size method, but I don't have an array. So let me really quick create to-dos array here. And let me temporarily store this to-dos in this array. And here I will get the size of my to-dos and print it to console. And again, Webpack it's already bundling everything into one file. And now if I go here, I open console, say my to-do 1, and say to-do count 1, my to-do 2, and I have my to-do 2. And again, in my network tab, everything is bundled in this app.bundle.js, jQuery, Lodash, and my app.js file. So this is an end-to-end development experience. You just need TypeScript, you just need Yarn and Webpack, and it gives you nicely automated development process. You can also, Webpack has many plugins. You can, for example, run your unit tests with it, the same like you can do it with Gulp. But this is your choice. You can still using Gulp. You can maybe you prefer Webpack. And one friend of mine, Remo Jansen, he created GitHub repo where he have this. It's called. Let me see how it's called. TSVS code boilerplate code. So this is like your TypeScript file new project. So if you're starting new TypeScript project, you can just go to this repo. You can clone it. This is what I did here. So let me go into here and let me open this with VS Code. And here in his repo, let me switch the slide really quick. Whoops, I don't want to print it. In his file new project repo, he's using Node.js. He's using npm. He's not using Yarn yet. He probably will update it soon. He's using Mocha and Chai for running the unit tests. He's using Browserify to module and dependencies management. He's using TSLint. TSLint is like JSHint or JSLint. How many people know what JSHint is or JSLint? Okay, half of the room. So basically JSHint, JSLint, and TSLint, and also ESLint, what it's doing, it's checking your code whether you're enforcing some conventions you agreed to, like for example, whether you're using double or single quotes. So for example, you can say, I want to use single quotes everywhere. If some developer would try using double quotes and we run linter on this, it will return errors. Or for example, in JavaScript, at the end of the line, you can, but you don't have to, use semicolons. So again, TSLint can enforce that you always use semicolons. Because if you read JavaScript good parts, you can see that there are some quirks that lack of semicolons can show you can cause some errors. So he's using that. He's of course using TypeScript, and he's also using Wallaby, which is a nice plugin for VS Code that allows you to run your unit tests continuously. So let me show you this really quick. Open my VS Code. Sure. The debugging VS Code? Yeah. Oh, TypeScript debugging. Sure. So to debug TypeScript, there are two ways. You can compile to JavaScript, and you can debug your JavaScript. Or you can generate the source maps for your TypeScript files. And then in Chrome debugger, if you supply the source maps, you can debug your TypeScript code. Sorry, I will not have enough time. Maybe after a session, you can stay off, or if I will have time, I can show you that, right? But you can debug either TypeScript or JavaScript. All right, so in here, let me close that. If we click Command equals, I think, Command Shift equals, click Start, it will run the Wallaby. You can see I don't have license, but that's okay. I'm just running for demo. And you can see you have this nice green marks here. So these are the unit tests written with Mocha. And here in this repo, there's just one simple module called greeter that is just returning hello, the greeting message that you create the object with. And here in tests, for example, it's creating new greeter with word exclamation mark, and it's checking whether it's returning the expected result. And of course, I can go here and I can say, hey, let me add the bank. I save this, and here I am getting red marks saying that this line of code is contributing potentially to my broken test. And then if I go to my test, it's telling me, hey, I expected hello world bang bang, but here it's only hello world bang. So it's a pretty nice plugin to run continuously your unit tests. I can revert it, and now everything is green again. And if you take a look at this code, here is a gold.js file. There's a lot of configuration he put in place to automate your development. So this is stuff you don't have to do. Like, in Visual Studio, when you do file new project for C#, you have a lot of configuration already in place. So this is the same idea, but for your TypeScript projects. And here is, for example, TSLint configuration. And for example, he has ruled that we only use spaces for indentation. So if somebody will use tabs, you guys know this tabs versus spaces war. You guys watch Silicon Valley? Who watched Silicon Valley? Whoa, like 5 people only? Come on, guys, you have to watch Silicon Valley. It's a great show. Yeah, there's a lot of configuration here. Of course, you can either remove it or you can configure it as you want. So strongly recommended. Check out the TSVS code boilerplate because a lot of configuration is put in place for you there. So at the end, I also want to mention how you can use TypeScript with existing JavaScript frameworks. And as an example, I choose Aurelia. I know that most of people now are very excited about React or Angular 2. And I was excited about Angular 2 as well, but that was around 2 years ago until I've seen Aurelia. Because what happened, I was following the blog of one of the Angular 2 developers. Rob Eisenberg, who after a while left the team and started working on his own framework, Aurelia, because he didn't like the direction in which Angular 2 was going. And then he wrote this blog post when he showed like how the Aurelia code would look in comparison to Angular 2. And after I've seen that, it was like a little bit suspicious for me, because I was thinking like, okay, so you probably chose like some example that is like exaggeration, and you probably have some huge JSON file with a bunch of configuration somewhere there. Okay, where's the catch, right? And then I look at that, and there was no catch. You actually can write pretty clean code, and you actually can write the code that is doing things. You can write your business logic, and you don't have to worry about all the ceremony that, like, for example, in React, to make hello world happen, first you have to write like 200 lines of code, right? And then your hello world is there. Like, I don't know if you guys have seen this article, how it feels to learn JavaScript in 2016. Who've seen this article? All right, like six people, so for the rest of the room. So here, yeah, check it out. So here basically the guy is saying that, hey, like, I need to display a newsfeed on my site, right? So how do I do it? Because I didn't do front end for the last few years. And so the guy is starting explaining him like, oh yeah, so like, what stack are you using? And he's like, oh, I'm not familiar with the stacks. Like, what's the current? Like, can I use jQuery maybe? Right? And he was like, oh no, man. Like, you need React. You need React. Oh, what is React? Oh, there's this cool framework, that allows you to do this really cool stuff. Okay, so I'll just use React and I'm cool. Oh yeah, but then you have to use also the React DOM to do the parsing and all stuff. Oh, what is React DOM? Oh, there's like another thing you need. Oh, okay, so I use React DOM, and I'm good. Yeah, sure, but then you should write it in ES6, because then you can take advantage of new features of JavaScript, of JavaScript vNext. Oh, wait, what is ES6? What is JavaScript vNext? And then he's explaining it, and then this article is going until it ends up that he needs like 100 different things to just display, and of course you need to use CDN, and then of course you need Webpack, you need System.js, you need bubble combo, and this is only like a half of the article, right? And then at the end you end up with this huge pile of code, and you have your news feed. Yeah, I was talking about Aurelia, yeah. I mean, with Aurelia, of course, you also can do all of these things, right? Oh yeah, sure, yeah, WebAssembly, yeah, so cool. Yeah, use that. Yeah, and oh yeah, Python, no. Yeah, really recommend you to check out this article. So I've seen that, and I was like, okay, so let me check this Aurelia framework. I went to aurelia.io, and the site looks nice, so that's a good sign. And there's this Get Started button here. I went there, and back in days it was looking a little bit different, but I just pulled the code, and here I have it on my hard drive already in basic Aurelia project. So this is the simplest project you can create with Aurelia. Let me close all other stuff, and let me open this. And here I have my index.html file. Here I'm importing System.js and some TypeScript config file, because you can use TypeScript with Aurelia. You can also use Bubble and use ES6 or JavaScript vNext, as some people like to call it. And here I'm just loading Aurelia Bootstrapper, and I'm saying that my Aurelia app lives in main file. So I go to source.main, and here is my Aurelia setup. It's using a default configuration, which in Aurelia, the convention over configuration is used everywhere. And here I can say, for example, app, but this is the default value. I can also say my app. Then I will have to change the name of this file, but I'll just leave the default for now, and I'll use my app.ts. And this is a simple to-do app, a little bit more sophisticated to what I created. And actually, let me run this. So I'll kill my HTTP server. I'll go to basic Aurelia project, and I'll spin up HTTP server here, and it should be the same server address like here. Run this, and here I can add to-do, my to-do, and enter, and it's adding to-do to the list, and my other to-do, it's adding to the list, and I can mark it as done. I can also remove it from the list. So it's very cool. So now, if you look how much code was written to make it happen, because this app.ts is basically all the code needed. There's also this simple to-do class, which have flag done and which has property description. But the entire logic is living in this app.ts file. And here I'm using heading, which I don't really have to use because I could just type it in my HTML file. So Aurelia is working in the notion of view and view model. So this is my view model, and I also have associated view. So let me open it side by side maybe. And here I open my app.html. So this is my view. And here on the left-hand side is my view model. And here you can see on my view, I am just injecting the heading variable. And it's already pretty nice that Aurelia is using this dollar and curly braces. Angular is using double curly braces. And by the way, the dollar curly braces is the same what the template strings in JavaScript are using. So it's even easy to remember. Another very easy to remember thing is how to create the bindings. So for example, in input tag, when I want to create a binding to do description variable, I just say value.bind. And this .bind work for any other tags. For example, I have checkbox and I have property checked. I say .bind equals to do .done, which is binding to the property done on this to do object. And this is going so on and so forth. And you also might notice that here, which is a very interesting thing about actually this approach, I am actually loading TypeScript in the browser. So it should be somewhere here. So this is my TypeScript compiler here. And I am loading TS files. So this is TS file, and there was a question about debugging. So like here, for example, I can go to app.ts, and here I can add some breakpoints. Let me put it up, and let's see. Here's add to do. So let me add breakpoint. Whoa, I cannot add breakpoint here. Oh yeah, you're right. Thank you, sir. I go to app.ts here, and here I add breakpoint. And now if I try to add to do, click enter, and I hit breakpoint, I can see that here it just grabbed the text, and I can go through it. So this is not, of course, recommended for your release environment, because in your release you should compile it to JavaScript and minify it and so on and so forth. But it's very nice for development that you can transpile your TypeScript inside the browser, so you don't have this compilation step. And if I do some change here, like for example, say to-dos and add some banks here, and I will refresh that, it will have this change right away without recompiling my TypeScript. And again, even if you have some developers who are not familiar with the framework, you can very easily get them started, because you might tell them, hey, what does that mean? I'm not moving. Yeah, all right, cool. Whoa, I cannot move? Wait. Okay, whoa. Oof, all right. So let's say we have this. Whoa, now we don't have audio. Different mic. All right, mic changes. Okay, we have like 15 minutes left. Yeah, sure. 2 mics. It's cool. All right. Yeah, I won't be doing it properly. Okay. I promise I'll get back to debugging. I promise. All right. Very last thing I want to show before I run out of time. So let's say you have this developer who doesn't know Aurelia, right? And you want him to write some simple logic. Let's say, can you get the first name and last name from the customer? Okay. So can you write the logic that it's taken from input fields and it's adding it to some list to logic in the app, right? And even one developer who knows Aurelia, he can do it for him. He can add these input tags and say value.bind equals f name, which will stand for first name, and also another tag which will stand for last name. And also I want to output it as full name, right? So developer 1 just wrote this code and then saying like, hey, okay, so I need to get this first name and last name for customer and display it somewhere else as full name. Okay, can you do it for me? So he's writing just JavaScript, right? So I say f name, and this is type of string, and I say public L name, which is also type of string. And here I also have, let's say, getter property, full name, which will return f name, this f name, $, and $this L name. And I will save that. And now if I refresh this, I should have this too. I have undefined, undefined. So this is very easy to fix because I can just initiate this first name and last name. I can do it in constructor. I can say first name equals nothing, and also last name equals nothing. And you see, I am not writing any framework-specific code. I'm only writing, oops, I don't want this. Say Jacob, check, and it's adding. And one developer just wrote this logic, and here's just only the minimal overhead of framework-specific code. So TypeScript can work in similar way with Angular 2, even as you probably know, Angular 2 is written in TypeScript. And TypeScript also works with React. There's this new format called TSX that transpiles to JSX that later on transpiles to JavaScript. And you can use it with all other JavaScript frameworks because, again, TypeScript is just a superset. You're just adding the type checking over your JavaScript. And if you're interested in JavaScript history, I really recommend you to check out the Douglas Crockford on JavaScript video series. It's a series of around, I think, 6 or 7 videos when he's talking about history not only of JavaScript, but also history of programming language and how we ended up where we are now and why it happened and what problems were solved with different programming languages. And if you like reading books, I recommend mention the JavaScript Good Parts. To learn TypeScript, there is a book, Learning TypeScript, which is not only about TypeScript, but also about configuring your development environment, using TypeScript with external libraries and the most popular libraries. And there are examples how to create end-to-end app. And there's also nice book, Effective JavaScript, which has, I think, something around 70 different examples. And it's showing, for example, this is how this works in JavaScript, because you probably know that, this has different scope. It has function scope in JavaScript, which is different than in object-oriented language. And here, one chapter is saying, okay, so this is how it works, and this is code sample and explanation. And this explanation is pretty concise. And the best place to start with TypeScript is go to typescriptlang.org. And actually, I think I didn't show it at the beginning. On typescriptlang.org, I can go here. There's this playground tab. And here you can, I've already written some TypeScript code that then compiles to JavaScript. And you can see it just stripped my string types from it, and you can even run it, and it will open new tab. Actually, it will output this to the console, so you can see here. There are some samples here, so you can see, for example, here I have just JavaScript that is compiled to JavaScript, nothing fancy. Here is some example how to use classes in TypeScript, and you can see that class is compiled to JavaScript prototypes. And there's also a documentation going over every TypeScript feature, and also a lot of samples how we can create even very sophisticated TypeScript apps. And there's also a nice Pluralsight course, TypeScript Fundamentals, that is like TypeScript 101. It talks about like classes, interfaces, definition files, all the stuff I was talking today, but a little bit more deeper. And this is everything what I have. And we have, I think, 5 more minutes, so I can show you the source maps ideas. So please don't leave yet. So if let's say I'll go to one of the examples I created. It was called my RWA2. Oops. My RWA, okay. So here I have this source. Here I have this app.ts file, right? So if you see the TypeScript compiler, oops, help. Here it has flag called source map that will generate for you. So if I say tsc app.ts source map. So now it compiled this and also create the app.js.map file for me. And I won't be able to run it now because I will have to integrate it with Webpack. And if I update accordingly the Webpack config, which I don't remember how to do it now, it could generate this map file for me, and then I could debug the TypeScript code inside the Chrome, like I was able to debug the Aurelia TypeScript. It's working in a similar way, and you can even take a look how this map file looks like. It's not very interesting stuff. Because why it's like that? Oh, it shouldn't be binary file. Oh, maybe they updated how they do it. Oh wow, I didn't even know that. It used to look a little bit differently, but like believe me, this is the file that is needed by Chrome debugger to debug your TypeScript. And if you look up on the Webpack documentation, I'm sure they have description how to configure it with Webpack, and you can also configure it in tsconfig. You can add this flag that automatically will be generated, and then you still serve JavaScript files, and in addition you serve this source map files, and then it can map it to like it was a TypeScript file. So thank you very much, and please evaluate the session. You can win a drone, I guess. So that's a pretty cool opportunity. And thank you for coming to my session, and have a great rest of the conference.